The most consistent pronunciation of this name right here that I have heard is Lipital. Some teachers will call it like Lopital. You know, pronunciation's a little iffy. And sometimes it is in fact spelled with the S in it so that it really looks like La Hospital's rule. So, in general, they are not going to count off on spelling. So if you got something close to Lipital there, then you're going to be okay on explaining here. It's one of the, it's like the I don't know what you call it. It's just like a little hat. Let me see if I can draw it better than I drew it here. You know, like that. Yeah, it's that. Whatever that is called. Is it called a hat? Okay, so the O has a hat. You definitely are not going to be, I do not normally write the hat over the O whenever I write this name out. So spelling, pronunciation is not super critical as long as it can be recognized as being Lipital's rule. So this is Lipital's rule. F and G are functions that are differentiable on an open interval containing AB that contains C, except possibly at C itself. Assume that G prime of X does not equal 0. Why can G prime of X not equal 0? It's on the bottom. For all X in AB, except possibly at C itself. If the limit of f of X over G of X as X approaches C produces the indeterminate form 0 over 0, then the limit as X approaches C of f of X over G of X equals limit as X approaches C of f prime of X over G prime of X. Providing that the limit on the right exists or is infinite, this result also applies when the limit of f of X over G of X as X approaches C produces any one of the indeterminate forms of plus or minus infinity over plus or minus infinity. Okay, so to summarize what this is telling you, this is a limit rule that is really useful, but I could not teach it to you whenever we were doing limits because we didn't know how to take a derivative whenever we were doing limits. And for this, you have to be able to take a derivative. So if you have some sort of limit that gives you either 0 over 0 or infinity over infinity or negative infinity over infinity, some sort of infinity over infinity. So if it gives you that indeterminate form, you can take the derivative of the top of the fraction and the bottom of the fraction and then find that limit there. Which a lot of times it may be impossible to find this limit, but it is possible to find the limit with the derivatives there. So let's look at what these problems will look like. So this is a problem that we can do without Lipital's rule, right? What would we need to do this problem? Just factor the bottom, right? So we can use this, but we don't have to use this on this problem. So if you are going to use Lipital's rule, I'm going to do all of these problems like they're free response questions. So if they are free response questions, you have to give certain pieces of information in order to use Lipital's rule. Because one of the big things that they really want to focus on is making sure that you know when you're using theorems or rules or different things that it actually applies to the situation. So the condition that you have to be sure of whenever you are doing these problems is that that has to give you 0 over 0. Here's what you cannot do, okay? You cannot do this. You cannot say this equals 0 over 0. Don't do it, okay? On the AP exam, it is going to depend on how many points your Lipital rule question is worth. Like last year, the Lipital rule question, you could get by with doing this because there was not a point for showing that condition. So you could get by with it. But if it's a 3-point question, one of the points is usually the condition. So we're going to do it. I'm going to count off for it every time if you you cannot put equals 0 over 0. The reason we can't do that is because nothing can equal 0 over 0 because it is indeterminate. So you got two ways to deal with this. And I have been researching this on my Facebook group, which is actually a pretty good authority on what can and cannot be done on the AP exam. There are two ways you can deal with it. One way is to show that the limit of the top is 0 and the limit of the bottom is 0. And that's what I used to make students do because at one training I went to, they said to do that. But I have found another way that I like better and is a little bit quicker. So here you cannot say that this equals 0 over 0, but you can say is of the indeterminate form 0 over 0. So we can't say that it equals 0 over 0, but we can say that it is of the indeterminate form 0 over 0. That may or may not actually end up counting off for us on the AP exam, but it's just best to do it correctly every time so that if it does end up counting for a point, we get that point, all right? So if this is of the indeterminate form 0 over 0, we can say by L'Hopital's rule, the limit as x approaches 4 of, I'm going to distribute that 3 right now, 3x minus 12 over x squared minus 16. So by L'Hopital's rule, our original limit is going to equal the limit as x approaches 4 of 3 over 2x. So I just took the derivative of the top and the derivative of the bottom. Not quotient rule kind of derivative, right? You're doing the derivative of the top and bottom separately, which is much easier than having to do a quotient rule. So now I can plug in 4, 3 over 2 times 4, and that is going to give me 3/8. Now this problem, if you get this problem on the AP exam, you can do it this way, or you could have just factored and canceled like we did on the warm-up, right? It would be fine because that problem can be done that way. Look at number 2. Okay? We should know how to do number 2 without using L'Hopital's rule. This time our limit approaches infinity. So if x approaches infinity, what is my limit going to be for this one? It's 0 because higher exponent's on the bottom, so that's Bobo-Botno. If it's bigger on the bottom, you get 0, right? So it is okay in this case just to say it's 0, but let's look at how L'Hopital's rule applies in this situation just because I want to see lots of different things. So now, do I get 0 over 0 if I plug in infinity? Which I kind of can't do, but I don't get 0 over 0, right? What do I get? In the top, if I'm doing 2 times infinity, that'd still be infinity, right? Then I subtract 7, which is not enough to overcome infinity, so it's still infinity in the top. In the bottom, 3 times infinity squared is infinity minus 9, still infinity. So this time we would say this is of the indeterminate form 0, I'm not, gracious me, infinity over infinity. So we can say by L'Hopital's rule. The limit as x approaches infinity. I'm going to write the original that they're asking me for. And I'm going to say that it equals the limit as x approaches infinity of 2 over 6x and in this case we would not get infinity over infinity. We would, as x gets bigger and bigger and bigger here, we'd end up with like 2 over infinity, which is 0. So we could say 0 there. Now, Bobobot knows a better way to do that problem. But what I see happen a lot of times once I've taught you L'Hopital's rule is that students start using L'Hopital's rule on every single problem, because you can use it on almost every single problem unless it's direct substitution. So I want you to see what it would look like if you did use it in this case. Yes? I'm pretty sure you can just say equals 0, and it will be fine. But if you try to use L'Hopital's rule, it needs to be done this way. So like if you are showing that you take the derivative, you need to put that if it's on free response, that it's of the indeterminate form by L'Hopital's rule, all of those things. So I'm pretty sure because it should be known that if you have a bigger exponent on the bottom, that this is going to equal 0, that you can just put equal 0 for that. So that's the better way to do the problem. But in case you are like focused in on doing this, this is how you would do it for this problem. Mm-hmm.
So we get 0 to that. It's like 2 divided by infinity. Come out to 0.
It will be it's going to get closer and closer and closer to 0 because what's happening is this number's getting bigger and bigger. So it's 2 over 6, 2 over 12, 2 over, and so it gets closer and closer to 0. Yeah. So if you have a number over infinity, that's going to be 0. All right. Okay, so here is another example, like one that we just did. There's other ways to do this problem, but let's use L'Hopital's rule to see that this will work. So if I plug in 0 here, I will get square root of 25 minus 5, which will give me 0 in top. I also get a 0 in the bottom. All right, so I'm going to say is of the indeterminate form 0 over 0. I don't want to say equals 0 over 0, but I can write this. Right? So we can say by L'Hopital's rule, the limit as x approaches 0 of the square root of 25 minus x squared minus 5 over x is going to equal. And so we're going to take the derivative of the top and the derivative of the bottom. On the bottom, what am I going to get? 1, which is good because now I'm not going to get 0 over 0 quite as easily without having the x in the bottom, right? So if I'm taking the derivative of this, I'm going to have, this is like to the 1/2 power, right? So I got 1/2 25 minus x squared to the negative 1/2 times the derivative of the inside, which is negative 2x. Hold on. Can this one be done by L'Hopital's rule? Why did I put this on here? Because this is still going to give us 0 over 0, isn't it? So that's going to go down to the bottom. Because you got that negative exponent, so we have negative x over the square root of 25 minus x squared. No, you'll get a number in the bottom. Yeah, you're right. You'll get 0. We're good. Never mind. Because we're plugging in. Yeah, because the minus 5 is gone, so we're okay. I was just thinking of it incorrectly. So I'm going to get negative 0 over the square root of 25 minus 0 squared, which will be 0 over 5, which will just be 0 for that. Now, I wouldn't say that's easier than multiplying by the reciprocal or by the conjugate, but it's an option if you forget how to do it the other way. Now, let's look at 4. 4, we do not know how to do any other way. Like, we're going to have to use, unless you know how to factor x to the 11th minus 1, which I do not know how to factor that. I guess you'd have to do synthetic division, which has been a long, long time ago, and we don't want to get into that, right? So this, if I plug in 1, I get 1 minus 1, which is 0. So it's is of the indeterminate form 0 over 0. So limit as x approaches 1 of x to the 11th minus 1 over x to the 4th minus 1 is going to equal the limit as x approaches 1 of 11x to the 10th over 4x cubed. Now, I don't think you're going to see this on a free response question, because what do you, no, never mind. We're good on this one. I was thinking of a different problem. So if I plug in 1, I got 11 times 1 to the 10th over 4 times 1 cubed, and I get 11 over 4. There. So the only way we know how to do this problem is to use L'Hopital's rule. So this is an example. Oh, I forgot to put by with L'Hopital's rule, didn't I? So the only way we would know how to do this one is with L'Hopital's rule. Let's look at some more where the only way we really know how to do this. Okay. All right, for this one, if we were to plug, first of all, we can kind of use Bobo button on this. What will we get for this answer? What's it going to be, Connor? Keeps going up, positive infinity. How do we know that? How do you know if it's bigger on top or bottom? E to the x is always bigger than x to any power. Even if it was x to 1,000,000, e to the x is eventually at infinity going to grow faster. An exponential is going to grow faster than x to any power at infinity. So this should be infinity for our answer. But to look at L'Hopital's rule for this, this is going to be, it is of the indeterminate, you can, we're going to have to here, form of infinity over infinity. So, limit as x approaches infinity of e to the x over x to the third is going to equal the limit as x approaches infinity of e to the x, because the derivative of e to the x is just e to the x over 3x squared. You're still getting infinity over infinity. So, this is the one I was thinking, I don't think you're going to see this on free response. Because technically, you need to say which is of the indeterminate form infinity over infinity. I think if you see this, it's probably going to be multiple choice where like you don't have to list this out every time. Because now you would have to say the limit as x approaches infinity of e to the x over 3x squared. Oh, and I'm still not doing biorbital's. You can see this one gets tedious with what you're writing each time if you have to do this. That's going to equal the limit as x approaches infinity of e to the x over 6x, which is still infinity over infinity, right? So technically you should write this one more time. So by L'Hopital's limit as x approaches infinity of e to the x over 6x is going to equal the limit as x approaches infinity of e to the x over 6. And finally, when you plug in infinity there, you're getting infinity over 6, which we can just say equals infinity. No, I should have written it. There's a chance you might see a free response where you got to do it twice. I don't think you're going to see it on free response if you have to do it more often than that. There's a good chance it could still end up on the multiple choice where you don't have to write all this out. You could just take the derivative, take the derivative, take the derivative, get your answer. But there's a chance you might see. Sometimes they will ask you. Sometimes they will just be limit problems, and they will say, find this limit. And you'll need to know that, well, actually, sometimes you don't need to know that you need to use L'Hopital's rule. As long as whenever you get 0 over 0, you can use L'Hopital's rule, even if we know other way to do it. But then there may be a few that you will see. And there are some that you have to use it. All right, let's look at this next one. All right, if we plug in 0 here, what is sine of 0? 0, what's tangent of 0? 0 over 1, which is also 0, right? So we're going to say is of the indeterminate form 0 over 0. So if I had 5x for both of these, I could change tangent to sine over cosine, and I might be able to work it out like that. But because I've got a 5x and a 9x, I cannot do that. So I'm going to take the derivative, well, I'm going to say by L'Hopital's rule. I'm going to say the limit as x approaches 0 of sine of 5x over tangent of 9x is going to equal the limit as x approaches 0 of, what's the derivative of sine? Cosine of 5x. But since I've got other stuff in there with 5, I got to take the derivative of the inside. That's going to give me 5, which I'm going to write out front here. All right, what's the derivative of tangent? Secant squared of 9x, and then I've got to put a 9 out front here. Now, cosine of 0 is 1. So I'm not getting 0 over 0 now. I can plug in. So I'm doing 5 cosine of 5 times 0 over 9 secant squared of 9 times 0. So what is cosine of 0? It is 1. All right, secant. What is secant of 0? Secant is 1 over cosine. Cosine of 0 is 1. So secant is going to be 1 over 1, which is still just 1, right? And it is squared because it's secant squared. And so we just get 5/9. Here. Okay. Questions on that one? Okay. Here is an example. I think this was a released question that I got from somewhere. Here's an example of something you might see on the multiple choice. So since I know this one's multiple choice, I'm not going to worry about doing the is of the indeterminate form and saying by L'Hopital's rule. But you have, well, actually, we do know how to do this problem. We should know how to do this problem. Does anybody remember how we did these problems? We did do these. We knew that the limit as x approaches 0 of sine x over x was equal to 1. So we would take like this, and that would be 1, and then we'd do cosine of 1. So we did do that. But it has been a long time, and I feel fairly confident that you guys have forgotten how to do that. In fact, I had forgotten it until it just popped in my head just now. So let's do this with L'Hopital's rule instead. All right. So I would have the limit as x approaches 0, and I'm being lazy on this because it's multiple choice and it doesn't matter if I show my work. So I don't have to do is of the indeterminate form. So derivative of the top, I've got to use product rule for. So I would have sine x times the derivative of cosine x, which is negative sine x, plus cosine x times the derivative of sine x, which is cosine x, over the derivative of x, which is 1. And if I simplify this a little bit, I've got negative sine squared x plus cosine squared x over 1, but y'all can put that if you want to. So we're not going to get 0 over 0 this time. If we plug in, we're doing negative sine squared 0 plus cosine squared of 0 over 1. And what is sine of 0? 0. What is cosine of 0? 1. And we get 1 there. I think L'Hopital's rule is easier just because there's not special rules that you have to remember for it. You just need to know that you can use L'Hopital's rule. I think it simplifies things a little bit because you can use the same method on every problem. Because almost every problem you're going to run into is going to work for this. So 1 would be our answer. Okay, here is an example of something they have been liking to do here lately on the AP exam that you definitely have to use L'Hopital's rule for. Okay, so the graph below shows the graph of f of x. The line tangent to the graph of f at x equals 0 is also shown. Okay, so if I plug in 0, I need to know if I'm going to get 0 over 0. So I'm going to show you another option for a problem particularly like this where you may actually need to show the work. So instead of saying is of the indeterminate form 0 over 0, because I really don't know if it's of 0 over 0 yet, I could do the limit of the top and say that would be 2f of x e to the x plus 4, which would be 2 times f of 0 e to the 0 plus 4. What is f of 0? Negative 2. So it's 2 times negative 2. What's e to the 0? 1. And what do we get here? 0. So the limit of the top is 0. The limit as x approaches 0 of the bottom, 3x squared minus 3x, is going to equal 0 there also whenever you plug it in. All right. So the limit of the top is 0. The limit of the bottom is 0. So you're getting 0 over 0 here. So then you could say by L'Hopital's rule. The limit as x approaches 0 of 2f of x e to the x plus 4 over 3x squared minus 3x is going to equal the limit as x approaches 0 of, what have I got to use to take that derivative? What? This one's not going to be calculator active. You've got to use a product rule right here, because this f of x and this e to the x both include x's in their separate expressions. So I'm going to leave that 2 sort of out front. I will have f of x times the derivative of e to the x. What is the derivative of e to the x? E to the x. And then I'll have plus e to the x times the derivative of f of x. What's that? F prime of x. And then the plus 4 is just going to be 0 right there. And then the bottom is easier to take the derivative of. We'll just get 6x minus 3. Now, I know in the bottom I'm not getting 0 anymore, so I'm probably good to plug in at this point. All right, so I'm going to have 2 times f of 0 e to the 0 plus e to the 0 f prime of 0 over 6 times 0 minus 3. Okay, they like to give you these problems because it really puts a lot of stuff together. You have to know f of 0. What is f of 0? It is negative 2. E to the 0 is 1. E to the 0 here is 1. What's f prime of 0? Negative 1, because it's the slope of that tangent line that they gave you. So it would be negative 1. And then in the bottom here, we're just getting negative 3. So we got negative 2 minus 1 over negative 3. So that is negative 3. We're going to end up with 2. There. It seems like they have really enjoyed putting this sort of L'Hopital rule problem on the AP exam the last few years. So I would not be surprised if you see something like this again. Okay, questions?